Hi, I will explain to you conditional probability such that hopefully this will be your final video you'll ever have to watch in order to understand its essence. The prerequisites to learn conditional probability is that you have an understanding of sample space, the basic probability formula, and joint probability. If you're not thorough with any of these, I would strongly recommend that you spend more time trying to get thorough with these concepts because we are going to use these here, and that will be confusing if you're not thorough with those. Now let's get started. I would love to explain to you conditional probability with the help of an example. So let's say, take an example of 100 people. So this will be our sample space. Of these 100 people, 50 are men and 50 are women. Of these 50 men, there are 10 who are 7 feet tall. So these are 7 feet tall people, and 40 who are not 7 feet tall. And none of the women are 7 feet tall. So the only people that are 7 feet tall are these 10 men. So it's a simple example. Now, here's an experiment. If we were to pick one person at random of these 100 people, what is the chance that this person is 7 feet tall? So that would be the probability that this person that we picked at random is 7 feet tall is equal to 10, because this is all the 7 feet tall people we have in the sample space of 100. So that would be 0.1. Now let's try joint probability. What is the probability that the person we picked at random is 7 feet tall and happens to be a man? In our simplified example, all the 7 feet tall people are men, there are no women. So the result is identical, 0.1. Now, let's act like, we have a breaking news, like news kind of update, that we now have additional information about this random person that we picked. And the update is that this person is a man. Now, the question is, can we incorporate this new information into our probability calculation and recalculate it? So, what I mean by this is probability that the random person we picked is 7 feet tall, given now that we know that this person is a man, the first thing we would do is exclude the 50 women, because now we know it's a man. So, our new sample space is 50 men. You notice that as a consequence of this update, our sample space has been reduced to half in our case. So the probability that the person is 7 feet tall, given that it is a man, that will be 10 by the reduced sample space, which will be 10 by 50. If we calculate this, you'll get 0.2. This is the recalculated probability given new information. This is conditional probability. Conditional probability is recalculated probability given new information. The word given, mathematically, we denote it with the pipe operator. So that would be P of 7 feet tall, given that this person is a man. This is conditional probability. Now, life is not simple. Here we got the numbers directly. We solve math problems using formulas. So the formula for conditional probability is probability, the joint probability that a person is 7 feet tall and a man, divided by probability that this person is a man. So the condition, the update, goes to the denominator. If you notice that we have already done this, that would be this, which is 0.1. So we add 0.1 here. We have no update here. What would be that? So it's 50-50. So that would be 0.5, right? Here we are not incorporating any update. We're just saying if we were to pick one person at random out of 100, what is the chance that the person is a man? So that's 0.5. We calculate this, that would be 0.2, which is precisely what we got. Now let's denote this formula in a standard way. Generally, the first part is denoted by an A, and the condition here is denoted by B. So the formula would be probability of A given B is equal to probability of A and B divided by probability of B. This is the formula for conditional probability. Now, back in the day when I was learning this, I experienced one confusion when I was solving problems. When I read a word problem, I tend to get confused if what they're saying is a conditional probability or a joint probability because they kind of sound the same. So I would love to give you an intuition now. If you remember, the joint probability is P of A and B. So probability of 7 feet tall and a man being selected is 10 by 100. So the sample space is not impacted. It's not changing at all. It's just when two things are happening together. That is when joint probability, A and B. Conditional probability is A given B, which is the condition has already happened. We already know that this person selected is a man. As a consequence, it impacts the sample space, the size of the sample space. But remember, the impact could be zero. For example, if the update was saying that the person that was selected happened to have a pizza yesterday, how would that make any difference? Because that is an independent event. Please go ahead and solve a few problems, and the confusion would go away. I promise you that. Well, I hope I was able to help you understand conditional probability. I would love to hear your thoughts. Consider subscribing. Thank you very much. Take care.